type stuff.
I mean, that is faster when you do it online, especially since we can put you at like 1.5.
Yeah, and then you can like work on your practice work
And
or whatnot.
sometimes, like, a lot of your videos are you just like talking to your class that you're actually teaching.
So I'm working to make more videos where it's me just teaching to the video, but the problem is then you don't get the feedback of knowing how well am I teaching. What's up? So, at the end of 15.4 here, I forget how far the video went. We were talking about researching a cell phone group and a no cell phone group. Interesting question.
Yeah, that is weird.
From how much sleep they get, depending on whether they have a phone or not.
I'm surprised there's no outliers on this.
So,
There'd be outliers like me. I have a phone and I sleep like 10 hours.
So we're gonna start talking about outliers today, dealing with mean absolute deviation and how far from the average are you. But what this starts asking is what's the interquartile range? So we gotta remember what are quartiles, what's the interquartile range? So Jeremiah, you had your hand up?
It was something for the cell phone things. I was gonna say, did you know cell phones they produce a certain chemical that makes your brain like it keeps it active. Like you know how people when they have their cell phone and they have it like next to them when they're trying to go to sleep, it makes it harder to sleep.
You
Also,
might
the
be
new
talking about
lighting
like
can go
radio
on your
waves.
phone, like you can set it for like a different time and it makes it so it's like light that you look at that makes you. Yeah, that's why they say turn on.
Okay, so we're gonna move on and talk about math. Thanks. So, did you guys get this answered through yesterday's interquartile range? So who can remind me what a quartile is? What does this even mean? What and the root of the word kind of helps us out. Honestly.
Well, I know how to explain it in the box.
Okay, so like what? Explain it via the box plot.
Okay, so the quartiles would be the first quartile would be the left-hand side line of the box,
How much of the data is in that?
and the third quartile would be on the rightmost side, and that would make up the middle 50% of the data, and so the second quartile is the middle line in between the box, and it's also the median. And interquartile range is quarter 3 minus quarter 1.
So you said that quartile 1
Yep.
is here. Quartile 3 is here. We can either call it quartile 2 or the median,
And that's the middle 50%.
which, well, is the very middle of the data, not even necessarily a point of the data. So remember, your median value, depending, and each of your quartiles actually may not actually end up being one of your data points, because we have to find that very dead middle. If there's an even amount of points, we got to average between two of them. So when we talk about interquartile range, well, we first got to figure out where these trace down to. So this seems like it would be 5. That seems like it would be what?
That's 7.25.
Ooh, so let's see how many tick marks. 1, 2, 3. It's broken up into 4 sections. So that is 7.25 or 7 1/4 if you want. So our interquartile range is
6.5. 6.5.
interquartile range.
5 to 7 or 2.
2.25. I do the subtraction. So I look at 7.25 minus 5 and my IQR for the cell phone group. The difference in the middle 50% of the data. We're talking about how tight is your data. It spans 2.25. The middle 50% has that big of a span. Look at your no cell phone group. Try to figure out your IQR on your own. See if you're able to do it. Sean, what's it go to? From and to.
It comes from 6.75 to 8.
So your IQR is? So what inference could we make about the data sets? How do we compare them then, Ozzy?
The no cell phone group has more consistent.
The no cell phone group's data is more consistent or closer in the middle of the data, right? So the middle 50%, that core that we look at, ignoring the top 25 and the bottom 25%, But now what if I look at the complete range? So I know it was saying based off the IQR, but if we for a moment look at the complete range, this starts at 4, goes to 7.75 probably. This starts at 4 and goes to 9.5. Now the range is bigger, obviously, but when you compare the groups, what sort of thing would you say? If you were trying to like present data, say this was a science fair project. Jeremiah?
Well, I feel like what you would want if you wanted to make this like actual like study more relevant, you would want a dot plot so you could see like when most people fell asleep. I feel like that would actually like help so that study would be
Yeah, I mean,
better.
you can manipulate the plots, but say this is all we have.
Yeah.
Say box and whisker is all we have to work with. What about the minimum of the data sets?
They were both at 4, but the maximum in the no cell phone group was like 9.5, and then the other one was almost 8.
So we could say that the range of the no cell phone group is larger, but it's larger in the way that some of them get a lot more sleep. So if we're trying to make comparison between the groups, well, if you're in the no cell phone group, you have a higher chance of getting more sleep because first off, your interquartile range is tighter. 75% of your data is above 6.75 and your data pushes further right. So if you're trying to make these comparative inferences or comparative statements, you just kind of got to think, how can I pull info out of this and not just present numerical, but kind of anecdotal? Questions?
What's anecdotal?
Things like stories, things that have actually happened. So saying somebody here slept 9.5 hours. That is like a representation of no cell phone group. He had a lot more sleep. The maximum person in the cell phone group was 8, and that was a person's response. So obviously, they're based on the data, you're going to get more sleep if you don't have your cell phone. So we just kind of pretty much talked about this, or the range and interquartile range. It's kind of hard to make complete statements. We'd probably want to look at the, what do we call those measures that talk about where the data averages out? Where there's a whole category. So it's like the mean, the median, the mode. Those are my measures of, Sam? Center, as opposed to range and interquartile range are my measures of, starts with a V. It's at the top of your notes. Variability or variation. So sometimes we want to talk about how much things vary. Sometimes we want to talk about where things center. So I'd really like to talk about the average. If I could get every single data point response, I'd like to know the average to talk about this stuff before I really make too many statements.
That's why I was thinking about dot plot, because then you can see like where most people actually fall asleep instead of just seeing the range.
Right. Sorry, this is still slightly wonky up here for me getting the capture. So, if we look at, and I like that they put this on the same number line. It's nice to put multiple box and whiskers on the same number line because you can literally compare, here's my interquartile, my middle 50%. Here's my middle 50%. So this data is much tighter in the middle. But what could we say about the data overall, comparing an outdoor group and an indoor group with their moods? So set yourself up, read the situation. Psychologists studying how spending time outdoors affects people's moods, serving a group of people chosen at random. So he chooses a group that's been hanging out indoor and a group that's been hanging out outdoor. Purple is your outdoor, green is your indoor. Ellie, what sort of things could you say about this?
I could say, because based off the data that I see, that the indoor group doesn't really, I'm assuming that 10 is happier.
Yeah, so like a 0 to 10 scale, right? How happy are you?
The indoor group is not much less happy than the outdoor group. And the quartile 3 matches up with quartile 1 or the indoor quartile 3 matches the outdoor quartile 1 in the mood scale.
So if we look at, and please notate this on your paper, I wish you guys could change like purple, green, whatever, but if we look at the purple group, their results below 6, like Ellie was talking about how spread out there or how close where the different parts are, this is 25% of their responses because the quartiles break your data up into fourths. But if we look at the data below 6, same cut line that we did with purple, is how much of their data?
75%.
75%.
I mean, there are those few people who are above 6.
So if we want to talk generally about the happiness of our people, what would you say?
People outdoors are happier.
People outdoors are happier. Based on the data we observe. We're not making like statements of fact. We're making statements of observation. Based off the data we have, 75% of our outdoor people who responded were between a 6 and a 10 happiness. Whereas only 25% of our indoor group were above a 6, and none of them were above a 7. So I'd be pretty confident in saying people outside are happier, and there's actually scientific research of why. What makes you happy when you're outside? Two different things. Well, okay, yeah, but two, like scientifically,
It's fun.
I think somebody said it. What does the sun give you?
Vitamin D.
Vitamin D.
Yeah.
You need vitamin D to survive, and it actually does like improve your mood. And
UV rays?
yeah, it's not the UV though. I'm pretty sure keratin also improves your mood, but vitamin D improves your mood. So go outside, soak up some sun. When they actually say like go soak up some sun, that's like an actual statement of science. Like go get some vitamin D in your body.
I like staying inside
People are 4 times happier doing a hobby than they are watching TV. By the way, so get an outdoor hobby and you'll be very happy. It is not true. Sean,
Are we gonna have more outdoor classes later?
if it gets above freezing. So we would hope, yes.
I don't think that's possible.
So check this out. Take a moment. Write down what you would say when presenting this data. Write down using like words and sentences, punctuation, all those things. Yeah, the last one. So now we've kind of stacked our data as opposed to putting it on 2 different box and whisker plots, because not everybody was able to talk about the other data. So if you look, this is the same comparison data as right here. However, we put it together on one number line. What about the overlap in the data? So some of the questions in your practice work, I was going to try to remember the number, but I forget exactly what I numbered it. We're talking about compare the 2 data sets and talk about their overlap. So, Colin, when we look at where these groups overlap, their overlap is between where and where?
7.5 hours and 4.
Yeah, their overlap is this entire section of the number line. So, in talking with the overlap, we could also talk about the not overlap, where this section, only people from the no cell phone group exist. Just like this section, only people from the outdoor group exist. So, both of these sets, and this won't always happen, and especially on your practice work, you'll see that this does not always happen. Both of these sets start at the same minimum, and then go to kind of dramatically different maximums. Most sets that end up at dramatically different maximums will also have different minimums, and they'll overlap in the middle, but the one will extend lower, the other will extend
Yeah,
higher.
that happened on 14.1 and 2.
Yeah. So when we talk about data sets, most of the time we don't end up just looking at one, we're comparing. So what if we collect data about 7th grade versus 8th grade? What if we collect data about boys versus girls? Like we're comparing data sets. Jeremiah Smith, what would you say about this data? What would you write?
Well, I did the example what I sent.
What would you write for the example?
Well, I put 75% of our outdoor group is happier than the
Ooh, be careful. You would actually want to change that to 50%, because if you're talking about how much of the group is happier than the other group, you stop your indoor group right there. And that, on the right side of that, is 50%. So I love that statement, though, actually. 50% of the outdoor group is completely happier than any of the indoor group. Which makes me sad that we have no windows. But yeah, that's a great statement. 50% of that group is happier. Here, that'd be a little bit harder to make. That'd be like 30, 35% maybe gets more sleep. Maybe we'll say 33% of that group gets more sleep. Because if we go from here to there. Katia, Moon, what'd you say?
I said that the other.
Who's doing that? How rude is that? Like, are you thinking about that when you're doing it? That somebody else is trying to answer a question? Then that's a root issue right there. You need to think about your behaviors. What do you think, man? Just any observation. Like, there's no right or wrong here. I'm just curious what you guys observe when you look at the data sets.
Well, if we're going out of 100, 33% of that is the yellow highlighted no cell phone. Then 67% is cell phone.
Yeah, like, there's 67% of the no cell phone group overlaps with the cell phone group. You could also make statements about the minimum. I'm surprised that nobody here is wanting to say, well, I can't get any less sleep by having a cell phone. Well, that's kind of a dangerous statement to make. Normally people are like, well, they have the same minimum, so what's the problem really? It doesn't like take me lower. Well, if you would have been up here in the no cell phone, then you probably end up down here in the cell phone group. Because look at how the data transfers. 25% has this tight of a spread. 25% has that wide of a spread. It makes you have much more variation by having the no cell phone because there's a very small amount of people down here. If I cut this off, this is maybe like 10%. So it's hard without the exact data points. But also, one of the things I'm trying to get at here is turn your cell phones off at night or stick them in the other room. It will help you get lots more sleep. I do too, but you can turn it on like do not disturb. So like no text, no push notifications, no. So like just don't have it like communicating with people. I don't have to do that, fortunately, because my peer group like understands that. But when I do have a friend that like sends a Facebook message or whatever at 11:30 or something, I normally like yell at them like, "What are you doing sending crap to me that late?" So now that we're sorry, you got a question?
I thought it was funny in your other video. You said how you kicked out.
Oh yeah.
How what?
It was like you said you had a sneeze limit and kicked out.
Yeah, we haven't really had to enforce that this year. 3 sneezes, you got to take a walk.
And then you said 4 if I let you. Wait, did they actually go leave your classroom?
Yes. I just told him to go get a drink. No, if you're sneezing that much, it helps to like reset. So it's funny, but at the same time, it should help you by standing up, getting things moved around a little bit. All right. So when we explore the overlap in the data set, and your homework is about to get a bit more complicated, and this is why I haven't made any of them live yet. I know some of you like working ahead, but when I throw out this giant word called mean absolute deviation, you're like, whoo, hey, what, huh? So we needed to talk before you try this homework. So, mean absolute deviation. Actually, if I go back to my start slide for a second, I might clone my start slide.
You just call it mad.
Yeah, you can just call it mad.
Alright, thank you.
So, but capital letters, periods after them. So acronym, capital letters, periods after them. So check this out. I'm just going to blow this up since we already had another start slide. To calculate our mean average deviation, we're talking about how far is this value, how much has it deviated? What's deviation mean?
Gone away from.
Gone away from
What you have.
like what it should be or what the normal is. So the normal is our average, right? When we talk about data sets, when we talk about measures of center, normal's our average. So when we want to talk about mean absolute deviation, I'm actually going to skip the example for a moment. We find the mean of the data set. So I would, if I was you, kind of activate your brain because you're going to want to use these notes as you do your homework. Step one is just get the mean. Average it out. How do we do that? Add them all up. So, jot yourself a little note just so you remember. This is sum divided by quantity. Sum divided by quantity. Then, we find the deviation. So if somebody calls you a deviant, it means that you are straying from what you should be doing or what the normal is.
Doesn't deviant like a synonym for evil? That's what I always
It can, like depending on how it's used. So like somebody could be deviant from their group, but if their group is a bunch of thugs and they're like, not, they're the deviant of the group. But so it has different applications. Are you laughing at me saying thugs? I often tell my wife that she's a thug. She likes to listen to like rap music and stuff. So, what's absolute value? What do I like to call the absolute value? Anyone remember my nickname for it? I say that sometimes middle schoolers need to take the absolute value. The attitude adjuster. So, gentlemen, get back with me, please. Mr. Cardiatis, get back with me, please. So, we want to talk about how far it has deviated from the average, but we don't care if it's above or below. So we need to find the absolute value. Please highlight this because otherwise you're going to get really screwed up values. All of my deviations should be positive. You can make that happen when you find them. If they're above, take bigger minus smaller. If they're below, still take bigger minus smaller. But then we're going to be using the average to start. We're going to do this here. So just hang on. Then we're going to take all the deviations and average those deviations. So check this out. This data right here.
How do you find a deviation?
We're going to do this. This data right here. If we average it up, we're going to add 7 plus 8 plus 8 because there's 2 8s plus 9 plus 10 plus 11, 11, 13, 13. So somebody help me out with a calculator. Let's average this up. Somebody else please help us out so we can verify it. Really, we should all be doing this.
You have to teach like a different class.
5. Well, per day 4, but yeah. What do you mean? How do I do this?
But you don't practice it like, but you already know what.
That's why you go to college to learn how to teach.
But you already know.
I'm also just a very animated person, so that's one thing that helps me out. What's the sum? Anyone get your sum?
90.
90, right? Thank you for the verification. So our sum here is 90. So you guys can write this right beside where we do it so you have a solved example problem. What was our quantity?
9.
9 data points. So I'm fairly certain also that's 10. Thank you, Manish. So now we need to find the amount of deviation. So if 10 is my average, my deviations, how far is 7 deviated from 10?
3.
It is 3 away. How far is 8?
2.
2 away, and there are 2 of them. How far is 9? 1 away. What's the deviation of 10? 0. Deviation of 11s? 1 twice. Deviation of 13? 3 twice.
Wait, what?
13 deviated from 10. So, after you write these down, give me your eyes so I can look into your eyes and see if you understand this. Really, your body language is how I most often understand if you get it. These are written out right here, but I wanted you to understand why. We know that 10's our average. That's our mean. That's the center of my data. I want to find out, with each data point that I have, how far from the average are you? 7 is 3 away from 10. both of these 8s are 2 away. This 9 is 1 away. The 10 is on the average. It's perfect. It has no deviation. The 11s are both 1 away, and the 13s are both 3 away. Any questions on how we found each of those deviations? We just figured out how far from 10. They have to be positive. So, this is funny because my wife is currently taking a statistics class, doing stuff like this for her Master's of Science in Allied Health. So, because she's getting a Master's in Science, you have to understand how to communicate data. If you're doing research, say you're in the medical field or like lots of different fields that need to collect research to support what they're doing, you've got to talk about your data. And to do that, you have to understand, is this point an outlier? People like to bring up outliers, but I have a feeling most of us don't really actually know what they are. Is that 7 an outlier point where I shouldn't really think about it because that's a weird situation? Or is it actually close enough to my data that it is included and it's not an outlier? That's actually the difference between a box and whisker plot and a box plot where you have disconnected or dotted or missing whiskers because points are so far away from the middle. Like, let's say this is data on how many, the ages of your kids or something like that. And somebody answered 2. Well, that's really far away from most of my data. So what we're trying to figure out is that point close enough to the middle or is it too far away? That's why we're looking at how much deviation is okay. We're going to the computer lab or something. So, we already know our quantity, 9. That's going to be the same. So when we divide this, we divide by 9, and we get that the average deviation. So please, because it makes more sense when you write it in a different way, the average, are we good to use the word deviation? We understand that that means difference from where you're supposed to be. So the average deviation is 1.8. So, how far away from the middle, the average, huh?
Approximately 1.8.
Yeah, so it was like 1 point, it's rounded to the tenths. So on your practice work, you're going to see problems that ask you about how many MADs or how many deviations. I forget if they abbreviate it to MADs or not, but how many of these is that point away? So if I look right here at my 11s, are those like 0 to 1 deviations, 1 to 2 deviations, 2 to 3 deviations? How far are they based on our average deviation?
1 to 2.
I understand how you do
Far
that.
away from 10. You see the 10 that we got from up there? We're trying to find how many away each dot is from 10.
So that was when we calculated the original deviation, right? So the deviation was 1. One, like, number. 1 away. But if we're talking about how many mean absolute deviations, that first mean absolute deviation, 1 standard deviation from the norm. Have you guys done standard deviation in science yet? So we end up getting, most of the times when we draw a data set, we get something similar, or we get a bell curve. Our data, most often, depending on what you're collecting data on, is centered in the middle. Most of the people that respond center in the middle. This is essentially like your median point, or your average. We then start to take steps away from the average. Within here, this span is your first standard deviation. Not 1 away from the point, but 1 standard deviation, which in this example is 1.8. So if this is 10, our average, then 1.8 away from it is going to be 8.2, or 1.8 above it is going to be 11.8. So the first deviation steps, what we end up later, you guys will call standard deviation. goes out to 8.2 or 11.8. If we go another step out for how far our deviations go, we'll go down another 1.8 or up another 1.8. So let's look at some actual data sets because we got like 10 minutes left. And I still, depending on how far we make it today, I may or may not make your homework live. So hang on. 1.8 is the MAD, the mean average deviation.
Don't you mean absolute deviation?
No. So the absolute deviations were when we were finding, the positive value, that list of red numbers, those were each of our absolute deviations. Every data point has an absolute deviation, because absolute just means positive, no negatives.
How could they ever be negative? Because it's distant.
Exactly. That's why there's no negative. Okay. You're answering your own question. So we then averaged all the deviations and found out that our mean average deviation is 1.8. Let's do another, because then you'll see how the spread of data affects things. So we've got a sample of second grade students, and we've got their heights here. If we tried to draw a curve on this, we end up with a curve that's going to look like that. And you don't have to draw that, but we want to calculate the mean average deviation when we know that the mean is about 50. Because they did it in inches, which is much easier than using feet and inches.
So we wanted to find the distance between each of those lines.
So we start by finding the deviations, right? So
We're supposed to find the mean.
they give it to us. There we go. So hold up. I would use red or something, like if you're able to, that shows we're talking about differences here. So Julian, you want to help me find the deviations of these points? So first point, what's its deviation? 7, thank you. And you can go ahead and start adding these, because you know you're going to have to. So, next, 3, because that's at 47. Then we got to start listing multiples. 2, 2, 2. 2, 2. So go ahead and list out all your deviations. We don't need to keep saying them out loud. You guys can list them out. And actually, I'm going to cheat because I'm lazy.
Did you get the answer already?
No, but you'll see what I'm doing.
That's smart. Oh, that's really
Or sorry, 3 times 2. That's a 2. 5 times 1. 4 times 0. People are going to think I'm crazy for using the 0, but I have a reason.
Oh my goodness. I'm so crazy.
3 times 2. Plus 2 times 3. Plus a 4, 5, 6, 7. Do we have another 7 at the end? Is that the deviation of?
Yeah.
If your average is 50. So I took a little cheat because I knew I was going to run out of board. I didn't have space to list out all my values. So instead of saying 2, 2, 2, I said there are 3 2s. Instead of saying 1, 1, 1, 1, 1, there are 5 1s. There are 4 at 0 deviation, 4 at 1 deviation, 3 at 2. So you can shorthand it if you want. Please, lots of us add these up because we have a great potential to make a mistake here. Then we're going to divide by how many data points. So 1, 2, 3, 4, 5, 10, 18. I think it's more than 21. 25, I believe. Yeah, there's 25 data points. What did we get for our sum? Jasmine? 48. Hang it back up. 48. So here, we ended up getting 48 over 25. And that gives me my 1.92 So that tells me the average deviation of this set is 1.92 away from the norm, or away from the mean.
Or is just the round to the nearest whole number though?
Well, sure, but I like specificity. So, approximately 2 is the mean absolute deviation. So, when we look at how much data sets relate, what we're really looking for is how many deviations overlap, or how much of the data set overlaps. So if we have red and blue data sets A and B, I'm trying to think of what set this could be. Maybe ages of kids randomly sampled at Cedar Point. So, data set A, I bet you they took this sample where? Snoopy Land. And I bet they took this sample, over by some of the, moderately sized roller coasters. I mean, 10, 11, 12, you're getting tall enough to ride those coasters. Here, they do it on a different day, data sets A and B. Well, now we've got more overlap. Now, data set B seems to be shifted down. Maybe this was taken on the midway now, out where you get a variety of answers.
Maybe A was taken on like a high school or college day break or something. Maybe it was that. What?
A would be like younger, right? So data set, if that's age, actually A would be younger. So, here, hold on. So we got to talk about how we compare. I'll come back to you. The mean of data set A is about 3.5. Mean of data set B for this, like these are two different things. If you have a hard time seeing that these are two different things, make some kind of divide on your paper. The mean here is about 10.5. There is a distance between them of 7. Here, our mean is about 3.5, but now our mean of B is about 7.5. So now there's only a distance of 4 between them. These data sets are much more related because their means are closer. So that means there are fewer multiples of the mean absolute deviation to spread them out. Means they're more related, they're closer, they're tighter, they're more familiar with each other. The data. So if you wanted less variability, thank you for reading my mind, you would look at whatever day this was taken on. If you didn't mind and you actually wanted to show greater variability, you might use this day. So sometimes researchers spin the data to present what they want it to. So you got to be very careful when you look at data of how was it collected, when was it collected, what bias could have been created, because I can be very strategic with how I collect my data and get my data to answer pretty close to what I want it to answer. Even how you ask the question. Remember the question on the homework that said like funny movie A and like lame movie B or something like that? Like if I ask a question like that, that puts bias in your head. Oh yeah, that movie was fun. Oh yeah, that movie was lame. Like I forget, it didn't say lame. Lame is a word that I use. So, let's talk about something real. Sorry, Sean, you had a question.
Oh, I was waiting for this one that it could have been taken around.
Yeah, maybe like the brothers and sisters were hanging out, whatever. So, here's my data results. The mean absolute deviation of each data set is 2. Please highlight that or underline that. The mean absolute deviation of each data set is 2. The mean of 2nd grade is 50. The mean of 7th grade is 61. So we've got our 50 and our 61. 61 would be 5 feet 1 inches. So remember, 12 inches in a foot, 60 divided by 12, 5 feet. So how many mean absolute deviations are there between The averages. Well, we know each has mean absolute deviations of 2. So what is the distance between these? From 61 to 50, Ozzy? It's 11. So if we want to talk about how many mean absolute deviations, well, the deviation between their means is 11. How many average deviations is that? If each deviation is 2, here's a deviation, here's a deviation, here's a deviation, here's a deviation, here's a deviation.
5.5.
So we've got 5.5 mads between. I am not going to make your homework live. So hold up. Also because we don't have class tomorrow. So this is a huge announcement, really. Like multifaceted. Friday, we're celebrating Pi Day. So, being that it was yesterday, but I got to get 7th and 8th graders together, so I just figured I'd do every Pi Day type stuff on Friday. And because I'm not seeing you guys tomorrow, it made more sense to just do it that way. On Friday, we're going to wrap up these notes. Then I've got a bunch of little video clips and stuff for Pi Day. Friday at lunch at some point, I'm still trying to figure out if I'll be able to get 7th grade and 8th grade together for this, but we will be doing our Pi memorization contest. So, don't just say, well, I'm not competing because Anisha's killer at it. There are multiple prizes for multiple participants. So, if Anisha's the only one who gets to 100, then all you got to do is beat the next guy. Alright? So, I will see you guys on Friday. Have a great day.